Welcome to another Intermediate Algebra video. In this video, we'll look a little bit more at graphing. We'll continue to use slope, and we'll look at writing linear equations in different forms. So here are our objectives for this video. We're going to graph a line using its slope and y-intercept. This will be the third of our graphing methods, of graphing linear equation methods. Then we'll use slope-intercept form to write the equation of a line. We'll use point-slope form to write the equation of a line. We'll write equations of vertical and horizontal lines. We looked at this going the opposite direction, and now we're going to do it backwards. And we'll find equations of parallel and perpendicular lines. Some notes for this section. This is a reminder you've seen these formulas in one way or another. Point slope is the one we may not have seen yet. So the slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. And then point slope form, this one contains a point, x1, y1, and the slope. And then the standard form, which we saw at the very beginning of this graphing chapter, in the standard form, ax plus by equals c. If you can write it in this format, then you have a linear equation, guaranteed. So just some reminders, for it to be in standard form, the a value, the coefficient on the x term, is supposed to be a positive number. So if you do some manipulations and that number's not positive, you can always multiply both sides of the equation by a negative, and that will take care of that. It'll give you the positive in front, and the other signs will also change. And then a and b are supposed to be whole numbers. So we talked about that they're allowed to be any type of numbers, but when we write it in this specific standard form, we want them to be whole numbers. So these are the three different types of equations that we're going to look at today. They're all linear equations. They're all the same information, just in a different format. We'll typically start out with slope-intercept form or point-slope form, depending on the information that we're given. And then we'll manipulate to whichever form the question asks us to present the problem in. So these are the three different types of equations, slope-intercept. Hold on to these. These will be important in this section. And then our other notes are on how to graph a line using slope and y-intercept. So y-intercept, remember, this is your y-axis. The y-intercept is a point on the y-axis. So if we have the equation in slope-intercept form, we know the y-intercept, so we can put a point there, wherever it might be on the line. And then we'll use the slope, rise over run, to get to the second point. So up or down, and then left or right, a certain number of units. Okay, so let's look at some examples. Okay, first, some graphing questions. Now, the directions don't specifically say what method you're supposed to use here. If in general the directions just say graph, it's up to you. You can find a bunch of random points. You can find the x-intercept, y-intercept, or you can use slope-intercept. So for this first one, our goal is to graph, and our equation is in slope-intercept form, which means we're presented some very helpful information. So let's extract the slope and the y-intercept. Our slope is 2, and as a fraction, which is what we'll need to be able to graph this, we can write it as 2 over 1. And then our b value, our y-intercept, is 5, as an ordered pair, 0, 5. Okay, so to graph this, as the steps say, let's get some tick marks on here. We'll change the color. Okay, so when we're graphing and we're using slope-intercept, we start at the y-intercept, 0, 5. 1, 2, 3, 4, 5. And then count rise over run to a second point. So from this point we go up 2. This is our rise. It's positive, so we go up. and then run 1, up 2, run 1. And that's where our second point can be. Remember, with a linear equation, it only takes 2 points to give you your line. So that's enough information. We have it graphed. Okay, let's look at another one. On this second problem, same objective. We want to graph this linear equation. We know it's linear because we have an x to the first power, y to the first power, and sure, there's a number. Doesn't need to be there, but we have first powers on these variables, x and y. All right, so again, this is in slope-intercept form, so we can extract that information. Our slope is -1/3, and our y-intercept is -4 as an ordered pair, 0, -4. You might be wondering if the negative should go with the top or the bottom. Does it mean the same thing? Well, let's say first that we do slope with the -1 on the top. Let's see what that looks like. And then we'll compare 1 over -3. So we have all the information we need to graph this. We just need to draw the graph. Change the color again. So we'll start with the y-intercept, which is 0, -4. There's this point. And then let's see where it takes us if we go with the slope of -1 over +3. The rise is -1, so we go down 1, and the run is 3 over, in the positive direction, 3. So here's the point. Okay, now let's compare, and actually let's connect this. Let's connect and make this line. You can see what this equation should look like. But now let's compare and see what it looks like if we had used 1 over -3 as the slope. So our first point would still be at the location 0, -4. And according to this slope, 1 over -3, we would go up 1, and then in the negative direction for run 3, so backwards 3. So that gives us a different point on the line. Again, these connect and form the exact same line that we got using -1 over +3. So when it comes to a slope that has a negative in front of the entire number, it's your choice. Give the negative to the top or the bottom, but it does need to be given to one or the other. This also kind of helps us to see, remember, from left to right, a negative slope tells us that the line is going down. From left to right, down. So this is what we would expect to see, a picture like this. If you, for some reason, ignored the negative and just did 1/3, your graph would have a positive slope going up, and hopefully you'd recognize that's something that you shouldn't have. The negative tells you it should be going down. All right, so to review, start with y-intercept, then graph, rise over run to get to your second point. So rise up or down, run left or right to your second point, connect, and you have your line. All right, let's do another one. So we have, again, the directions say graph, and if they just say graph, it's your choice on how you do it. But for this section, I'm going to go through the problems using slope-intercept form. So here's the given problem, and if we want to use slope-intercept form, what do we need the equation to look like? Currently, the equation is presented in standard form, but to use slope-intercept, we need it to be in slope-intercept form. What does slope-intercept form look like? This is when we have y equals everything else. So we need to solve for y. All right, so let's subtract 2x from each side. We have 3y equals -2x plus 3. And then divide every single piece by 3. We get y equals -2/3 x plus 3/3, 1. Now we have it in slope-intercept form. Now we can go right into graphing. This is one of the only places that you'll be happy to see a fraction, or at least not so disappointed. So let's set up this graph. Okay, so we start at the y-intercept, which is 0, 1. And then we count rise over run, -2 over 3. So down 2 and forwards 3. Connect. And we have our line. Good. Okay. So let's look at a different type of problem now, and this is writing the equation. So we've done a lot of, here's the equation, graph it. Now we're going to go the other way. We're given some information about pieces of the graph, and we are going to build the equation. Another very important piece for problems like this will be identifying which form of the equation we want our answer to be presented in. Remember, there were 3 different kinds on that note slide, so you may have to reference that to come up with the formulas again. Okay, so this question asks us to write the equation in slope-intercept form given this information, given that the y-intercept is 0, -2, and the slope is 4. Now, you can always start out presenting the problem in whatever way you want to. You can use any of the 3 to start out with. You then just have to manipulate it to be in the format that you need. All right, so this one wants the equation presented ultimately in slope-intercept form, which is y equals mx plus b. Okay, so this is ultimately what we're going for, but based on the given information, which equation should we start with? Should we start with standard form? Well, standard form has a, b, and c, and a, b, and c don't have any specific value in the meaning of the graph. They're just coefficients on x, y, and then a constant. Then we have point slope, and point slope is the most helpful when you have a point and the slope. And finally, we have slope-intercept, and this is most helpful when you have the slope and the y-intercept. In this case, we have slope and y-intercept, so we're going to go with that formula. Okay, so if we are given this information, the y-intercept is 0, -2, then what is our b value? Remember, the b value is just the y coordinate of the y-intercept. So we know that our b is -2. And then our slope is 4, which is our m value. So we can plug that into the equation, 4x minus 2. Okay, then we make sure that the way we're presenting the equation, because this is a linear equation, we have it right here, x, y, numbers, all variables to the first power, do we have it in the right format? And the format we want is slope-intercept, so this is it. What if the question asked for you to present this in standard form? If we were asked to present this linear equation in standard form, we could still absolutely start out this way, but then we have to present the problem a different way. So in standard form, we have ax plus by equals c. If that's what we're looking for, then we need the x term on the other side, right? So we could subtract 4x from each side. I'm doing it from underneath the box, leaving us with -4x plus y equals -2. But then remember that in standard form, this a value is supposed to be positive. A, b, and c, whole numbers, and a is supposed to be positive. So we'll do one more manipulation. We'll multiply each side by -1. We can always choose to do whatever we want to both sides of an equation. It won't change anything. It's just adding more weight to both sides of the scale. We're still presenting equal information. So if we multiply both sides by negative, we get positive 4x minus y equals positive 2. So if it asked for standard form, this is where we would end up. This question only asked for slope-intercept, so this is our solution. But if it asked for standard, just know that's what you're doing. You're manipulating the equation to be presented in the way that it's asked for. Okay. All right, let's do a little practice. So go ahead and write the slope, write in slope-intercept form and then graph. So I do want you to use slope-intercept to graph this problem. And then the second one, write the equation in slope-intercept form given the following information. So you'll choose which one you want to start with, which one you think is the most helpful, and then manipulate the equation and present it the way that it's asked for. Go ahead, pause the video, and I will see you in a few minutes when you're done with these problems. All right, let's take a look at them. So the first one, we want to write it in slope-intercept form and then graph. We need y by itself, so we'll subtract 2x from each side. I can choose to write the right-hand side of the equation however I want. I could do 12 minus 2x or minus 2x plus 12. I'm choosing this way because slope-intercept form is y equals mx. I want the x term first, plus b. Divide everything by negative 3. Y equals positive 2/3 x minus 4. So here's the first thing. The equation is written in slope-intercept form and then graph. Red. So we'll start out with the y-intercept, 0, negative 4, and then count rise over run using slope, up 2 over 3. Okay, there's our graph. Then for the second one, ultimately we want the equation in slope-intercept form. So ultimately, we want to present it in this format, y equals mx plus b. But now how should we start? We typically, I can't imagine a situation where you start with standard form because a, b, and c don't have any specific values or specific meaning in the context of the graph. But the other two do have meaning. So we have 2 points presented to us. The first thing we need for either of the two equations, this is how we want to present it, but our other equation, y minus y1 equals m times x minus x1. Point slope form, the one we can use to start out with. For either equation, we need the slope. And if we have 2 points, we can find the slope. So if you felt more comfortable, you could graph those 2 points, and you could count rise over run, or you could use the slope formula. Slope formula. So we have y minus y1, 6 minus 4, over y1 minus y2, or vice versa, y2 minus y1 over x2 minus x1, negative 2 minus 2. So we get 2 over negative 4. A very common error is to say there's division and the number 2 and 4, so it's 2, but you have to do it the right way. That would be the case if it was flip-flopped, if the 4 was on the top. But it's on the bottom, so we just simplify this, negative 1/2. There's no good reason of moving the negative up top. That's just the way that I write it. Negative 1/2. You can keep the negative on the bottom. Doesn't matter. Okay, so we have the slope. Now we have to decide which one should we use. Ultimately, we want slope-intercept, but one of the points we're given is not the y-intercept. So it's really up to you. Both methods can be used. Well, let's take a look at both. Let's say we start with slope-intercept. We know the slope is negative 1/2. And the only thing we need to complete this equation is b. Now, we don't have b, we're not presented b, but we can find it. We can use one of the 2 points, either one, to find b. Let's say we plug in the first one. If we plug in the first point, that's an x and a y, then we'll have one variable left, b. So we plug in 4 equals negative 1/2 times 2 plus b, and then solve for b. 4 equals negative 1 plus b, add 1 to each side, we get b equals 5. So take this and go back to the line where we were very close to our answer and plug it right in. Y equals negative 1/2 x plus 5. This is one way to find the equation, and it's presented in the way that we want it. The other way we could get here is by using point-slope form. So if we started with point-slope, y minus y1 equals, we have m, which is negative 1/2. Then we plug in one of the 2 points. It doesn't matter which one. I'll plug in the second point just so you can see it done 2 different ways. We have y minus 6 equals negative 1/2 times x minus negative 2. Now, this is a good form of a linear equation. If we were just asked to write the linear equation, this would be enough. That's all we would need. But it's asked for you to present it in slope-intercept form, so we have a little manipulation to do. The only real problem we have is that it needs to say y equals, so we need to get everything on the other side. Let's clean up the right-hand side first. Distribute that negative 1/2 to this plus 2, so negative 1/2 times x, negative 1/2 x, negative 1/2 times 2, negative 1. Then we want y by itself, so add 6 to both sides. We get y equals negative 1/2 x, negative 1 plus 6 is plus 5. So we come up with the same equation, no matter which way we get there. So you have some options for these problems. You can start out with whichever form of the equation you want to, as long as you ultimately then present it in the way that it's asked for. Now, I showed both ways, but you do not ever have to use both ways. I wanted to show you that it's possible to work from either one to get to your final answer. All right, good practice. Okay, let's do another few example problems together. The majority of this section deals with these types of problems, so we'll spend a good amount of time looking at those. Okay, so our next problem, find the equation in slope-intercept form given negative 1, 1 and 2, negative 1. Same type of problem that we saw in the last, on our practice page. We're given 2 points. We want to present the equation in slope-intercept form, which ultimately looks like this, y equals mx plus b. So we choose, how do we want to start? Well, no matter which of the 2 equations, point slope and slope intercept, we need the slope. So I'm going to start there. M equals y2, negative 1, minus y1, 1 over 2, minus negative 1. In the numerator, negative 2. In the denominator, positive 3. Okay, and I'm going to continue using slope-intercept. So I have y equals negative 2/3 x plus b. The only thing I need is b. That's the only thing left. And if you chose to use point-slope form here, that's completely fine. You can always go with that equation as long as in the end you present it the way that it's asked for. Okay, so we need b. I'm going to use one of the 2 points to get to b. Let's go with, doesn't matter, but I'll go with the second point. So we have 2 equals negative 2/3. Oh, whoops, nope, I want y there. Negative 1 equals negative 2/3 times 2 plus b. All right, so multiply these fractions. We get negative 4/3 plus b. We still just need to figure out what b is, so add 4/3 to each side. And we get b equals, now this part, if you were in Developmental 2 or a previous math class, you may have been asked to find this by hand. And that absolutely still works. You can take negative 1, find a common denominator, convert, add them together, or you can use your calculator. You can type in negative 1 plus 4/3, hit enter. The 4/3 just looks like division, 4 over 3. And it'll spit out a decimal, but remember, you can tell your calculator to change it to a fraction. The button up at the top left-hand corner that says math, you hit that. The first option says change to fraction, hit enter. Now it's telling the calculator the command, take my answer, change it to a fraction, hit enter, and it spits out the number you want, which is 1/3. 1/3. Uh-oh, a little higher. 1/3. There we go. Good, so we have the b value. Take it and plug it right back into that equation. Negative 2/3 x. It's a positive, so it's plus 1/3. And now we make sure, are we presenting it in the way that the problem asked? And we want slope-intercept form. This is in slope-intercept form, so we're good to go. If you chose to go the other route, you would most definitely get the same answer here. It would just take you maybe longer, maybe shorter. It always just depends on the numbers. All right, let's do another one. Okay, so for this one, we want to write the equation of the line in standard form, given the graph. So we're given the graph here. Okay, standard form is ax plus by equals c. So ultimately, that's how we want to present this. And we have to decide which one do we want to start with. It's up to you. I'll use point slope for this one. There's no reason why one is better than the other. It's a matter of choice. So if I want this to be a linear equation, I need to fill in the m, the slope, and a point. How you find those two things, you have a lot of options when you're given the graph. From the graph, you can pull any of these points off. We have quite a few that are solid on the line. Or, well, for the point, that's what you'll have to do. For the slope, if you want, you can identify 2 points. This first one is 0, 4. The one over here is 2, 2. You can take those 2 points, plug them into the formula for slope, or you can count rise over run. If I start, the graph's in red, let's go this route. If I start here to count rise over run, I'll be going up 2 units and then backwards 2 units. So up 2, positive 2, backwards 2 for running negative 2. And this simplifies to negative 1. So my slope is negative 1. Then plug in one of the points. It's up to you. I'm going to go with 2, 2. So we have y minus 2 equals negative 1 times x minus 2. Again, if the question only asked you to present the linear equation, this would be good enough. But this one asks for it in standard form. So we need to manipulate it and get it in this format. ax plus by equals c. Well, to get it there, we definitely need to distribute. So we have negative x plus 2. We want x and y on one side, numbers on the other. So we'll add x to both sides. And then add 2 to both sides. We get x plus y equals 4. Here is the equation presented in standard form. I'm going to go ahead and run through this quickly as if we had chosen slope-intercept form. If this is what we started with, we would still have to start out by finding the slope. Count rise over run, use the formula, whatever you want to do. Negative 1x plus b. But for this one, since we're given the graph, sometimes it's not a specific point that's kind of labeled for you, but in this one it is. We can see a circle, a red circle dot at that location on the y-axis. So based on this ordered pair, we know that the y-intercept is 4. So you could go ahead right away and plug in that 4. We're just pulling from this ordered pair. This is the y-intercept. Okay, so again, if the problem just asked you to present a linear equation, this is good. but we want it in standard form, so bring the x term over to the other side, plus 1x, or just x, and we get x plus y equals 4. Same equation. There's only one equation that works for any line. How you present that equation can be in different formats. You can present it standard form, slope-intercept, or point-slope. Okay, good. All right, I think one more here. A couple more. All right, find the equation that goes through 2, 2 and is parallel to y equals 5x minus 2. So this brings in one of those later objectives, finding parallel and perpendicular lines. Find the equation. It doesn't say in what format we have to present that equation. It just says find the equation that goes through 2, 2, so that's a point, and is parallel to y equals 5x minus 2. Okay, so what do we know about parallel lines that would help us build an equation here? Here's an example of parallel lines again. What do we know about them? If you remember from a previous video, parallel lines have the same slope. The same slope. And just so you have it again for a refresher, our equation is parallel, but perpendicular lines also have a special relationship. Their slopes are negative reciprocals of each other. Negative reciprocals of each other. All right, so our problem, we have the same slope. So looking at this equation, can we pull the slope from this line? This is one line, and the new line we're trying to build is parallel to this line. Well, the slope of this line is 5, so the slope of our line, let's write this, the new line, is also 5. So we have slope, and we have a point. Now we can build the line. We can build the equation. You can start out with whichever way you want. Let's go with point slope. Y minus y1 equals m times x minus x1. So we have slope and we have a point. Y minus 2 equals 5 times x minus 2. All the information is plugged into this equation. We have an equation of a line. How does it ask for this to be presented? Find the equation. Doesn't say anything specific, so this is good enough. If you manipulated this and presented it in a different format, that's also fine, but this one's good enough. If it doesn't say anything specific, you don't need to change it anyway. Good. Okay, let's look at this next objective of writing the equation of vertical and horizontal lines. So we'll do them at the same time again, just to kind of refresh your memory. Okay, so we want the equation of a vertical line that goes through -2, 1. You don't have to draw the graph, but I'm going to draw the graph for each of these. And for the second one, we want the equation of a horizontal line that goes through 3, 5. All right, so here's what this will look like. Here's the point, -2, 1. And this one, we have a vertical line. Vertical, up and down. And the other one, we have a point at 3, 5, and we want a horizontal line. Now you can go through the processes like we did for the other problems. Maybe look for slope, find a point, plug it into one of the two formats. But if you're asked for a vertical or horizontal line, remember from a previous video, those have very specific looking equations. They're very specific in one way. So what do you notice about this vertical line? Well, it's at -2, 1, and then every point along here exists. So another point would be -2, 0, -2, -100. You can see all these different points here. So the thing that they all have in common, because it's a vertical line, is this -2. and it is the x-coordinate. So if you remember, x equals that value, -2. Last time we looked at graphing from the equation, now we're looking at from the graph building the equation. So here's the vertical line. Horizontal, I'm sure you can guess. If the vertical line is an x equals line, then the horizontal line is a y equals line. The thing all of these points have in common is the fact that y equals 5. Doesn't matter what x is, it can be anything. It won't change the fact that y equals 5. There's no good strategy on finding these other than really kind of remembering how vertical and horizontal affect the equation. Vertical is an x equals line. Horizontal is a y equals line. And these will never be asked, you'll never be asked to present these in any sort of special way. They can be written in those ways, but there's it's a little trickier. So typically you'll just see them presented as x equals and y equals, and that's fine. All right. Okay, so some practice problems. I think we have just 2. Write the equation in standard form given the slope, m equals -4, and the point 0, 2. And then write the equation in slope-intercept form that is perpendicular to y equals 1/4 x minus 6 and goes through the ordered pair to 8. Go ahead and pause the video, try these practice problems on your own, and we'll go through them together in a moment. All right, so let's look at these. Our first one, write the equation in standard form. Ultimately, we want this presented, ax plus by equals c. And we're given m equals -4 and 0, 2. So it's your choice on which of the two formats you start out with. I'm going to go with slope-intercept because I have slope, and this point that I'm given is the y-intercept, which tells me that b is 2, and m, we already are given, is -4. So this is how I'll start, and then fill in what m is and what b is. But then I ultimately want this equation presented in standard form. So add 4x to both sides. We have 4x plus y equals 2. ax plus by equals c. It's in the right format. X term, y term, c on the other side. Good. And if you use the other equation, you would definitely still get to the same final answer equation. Okay, the second problem, we ultimately want it presented in slope-intercept form. And we have 2 pieces of information. The easier piece to digest, it goes through 2, 8. And the other information, it's perpendicular to this line y equals 1/4 x minus 6. So what does that tell you? Remember, perpendicular lines have a specific relationship. Their slopes have a specific relationship. Their slopes are negative reciprocals. So if the slope of the given line is 1/4, then the slope of the new line, negative reciprocal. So negate and flip upside down. -4/1, which simplifies to -4. This is the new line. This equation represents some line, maybe this one. We are finding the equation of the perpendicular line. So we have the slope, we have a point, however you choose to go about it. I'll go with point slope since that's the information we have. So we have a point at 2, 8, so y minus 8 equals -4 times x minus 8. And we want this equation presented in slope-intercept form, so distribute the 4 ultimately so that we have y equals blah, blah, blah. Plus 32, add 8 to both sides, plus 40. So here is the equation of the line in slope-intercept form. That's perpendicular to this line. We know it's perpendicular because its slope is -4, negative reciprocal, and it goes through the point 2, 8. We use those two pieces of information. Oh no, darn it, 2, this is 2. Whoops. Which changes this one. 8, whoops. And 16. There we go, 2, 8. Distribute, plus, good. So y equals -4x plus 16. So this equation in slope-intercept form, perpendicular to this line because we have our negative reciprocal slope, and goes through 2, 8. We use those two pieces of information to construct this equation. All right. I believe, yes. Okay, so that was a look at a little bit more with slope and our third method of graphing. We kind of finished up with 3 different methods for graphing, using random points, using x and y intercepts, and then using slope-intercept form. And we also looked at writing equations of linear equations with different formats. So starting with some information and then presenting information in a specific format.